Next, we go to the lossless media. For the lossless media, the sigma is equal to 0. Okay, that means there is no leakage current or no conduction current exists inside the material. And the loss tangent sigma divided by omega epsilon is also equal to 0. There is no loss tangent in the lossless media. So the intrinsic impedance can be simplified to Z mu divided by epsilon. And the phase difference is 0 because when this part is 0, so there is no J components. So it will be in phase. Okay, so it's 0. And alpha is equal to omega mu epsilon divided by 2 as the power of 1 over 2 minus 1 is equal to 0 because there is no attenuation in the lossless media, where the beta can be simplified into omega Z mu epsilon. Because what? Because this is a 1 plus 1 equal to 2, so we can cancel out here. Okay, we can cancel out. This is a 0, that's why you got 1. So for the lossless media, we can see that basically the electric field and the magnetic field will be in phase. There is no phase difference. The only difference is the magnitude of H naught is equal to E naught divided by intrinsic impedance. And if we can see the general equations here, okay, it's almost the same. So it's in phase because there is no theta. Let's see example 3. In a lossless medium, the intrinsic impedance N is equal to 60 pi and mu R equal to 1. The magnetic field is given by minus 0.1 cos omega t minus z x ampere per meter, and you have to find E. So from these informations, we know the magnitude of the magnetic field, and also this is the direction of the propagations, as well as the direction of the H field, the oscillations. Right, because this is a lossless case, so this is the case of in phase. There is no phase difference between electric field and magnetic field. Right, so we have to write the general equation for electric field, which is E equal to E naught cos omega t minus z, and the direction of E. So we have to determine what is E naught. So the E naught equal to the magnitude of intrinsic impedance multiplied by the magnitude of the electric magnetic field, which is equal to minus 6 pi. And then the direction of E, basically the EAP is equal to the AE cross AH. So the direction of propagation is Z, H is X. So what is E? So this is the sequence. So please follow the sequence as usual to avoid confusion. Right. So what multiplied by S, we got Z. So the X is here. So the Z here. So it should be in these directions. So it should be minus Y cos X. So it should be minus Y as mentioned here. So this is, and then we put everything inside the expression of E. So this is the magnitude and also the direction. So we solve the problem. Right. Um, for the case of free space media, so the sigma is still zero because there is no conduction current in free space. Conduction current cannot flow in free space, as we know. The difference is only we have mu equal to mu naught because our mu r and epsilon r is equal to 1. So this is the reference value, because we always refer something with a free space. And the loss tangent sigma divided by omega epsilon equal to 0 because this one 0. And the alpha and beta can be simplified into the same, basically almost the same. This one 0 because there is no attenuation part. And here we have mu naught epsilon naught. Compared to the lossless, we have mu and epsilon. Here beta is equal to mu naught epsilon naught. So this is a u is equal to velocity of the wave equal to uh, omega divided by beta equal to 1 over third mu naught epsilon naught. So this is equal to c. C is basically the speed of light. Okay, 3 multiplied by 10 power of 8 meter per seconds. And the standard for the intrinsic impedance for free space, we label as the N naught. Okay, naught means the in free space, the reference value. So it's equal to third mu naught over epsilon naught equal to 377 ohm. This is a very important value, especially when we want to design or characterize the electromagnetic devices such as antenna, filters, and so on. This is the value that we almost use, 377 ohms. And the theta n is equal to 0 degree. That means the electric field and the magnetic field will be in phase. Okay, you can see here the E field and H field in phase except the magnitude, because the magnitude of H naught equal to E naught divided by 377. Right. So this is basically the uh, intrinsic impedance in free space and not. And you can see the expression also simple. There is no phase difference. The propagation of the waves in the same direction z, and this is the oscillation directions E in x, H to y. And again, I would like to remind that these component can be different. It depends on the question. It can be y, it can be z, and this component also can be different. So please be careful.